Hello students, welcome to the lecture 10 of unit 2nd Organic Fuels. Before starting, just the recap of the lecture 9. Yesterday we have discussed need of cracking, types of cracking, in which thermal cracking and the catalytic cracking was discussed. In thermal cracking, we discussed about the liquid phase thermal cracking and the vapor phase thermal cracking. While discussing the catalytic cracking, we have discussed about the fixed bed catalytic cracking and moving bed catalytic cracking in the detail. Now, in today's lecture, we are going to discuss about the synthetic petrol, in which we are going to discuss Fischer-Tropsch process and the Bergius process. So, let us start with the synthetic petrol. The great demand of petroleum has necessity to synthesize petrol by chemical methods, and the petrol which is synthesized by chemical means is called the synthetic petrol. Main methods to synthesize the petrol are the Fischer-Tropsch process and the Bergius process. In today's lecture, we are going to discuss both of these processes in detail. So let us start with the first process, that is the Fischer-Tropsch process. In Fischer-Tropsch process, the raw material used to synthesize the petrol is the water gas. Water gas is the mixture of carbon monoxide and the hydrogen. This water gas is used to synthesize the petrol in the Fischer-Tropsch process. The catalyst used in this process is mixture of cobalt, thorium, magnesium oxide and the calcium. The temperature maintained in this process is the 200 to 300 degrees centigrade, and the pressure is the 1 atmospheric pressure, that is the normal pressure. This is the construction diagram of the Fischer-Tropsch process plant. As we see that this plant contains two purifying chamber, first and second purifying chamber, the reaction chamber, the cooler and the fractionating column. First two chambers are the purifiers, which contains iron oxide and iron oxide plus sodium carbonate respectively. Basically, these purifiers are used to remove the impurities present in the water gas. Basically, this water gas contains two types of impurities. First is the inorganic sulfur impurity and second is the organic sulfur impurity. So, when water gas is passed through the iron oxide purifier, this iron oxide removed the inorganic sulfur impurities from the water gas. So, inorganic sulfur is removed in first chamber. After removing the inorganic sulfur impurities, the water gas is passed to the next purifier, which contains mixture of iron oxide and the sodium carbonate. This mixture removes the impurities of the organic sulfur present in the water gas. So, in both of these chambers, iron oxide removes the inorganic sulfur, while mixture of iron oxide and sodium carbonate removes the organic sulfur compound impurities from the water gas. So, after purification of the water gas, this water gas is passed through the reaction chamber. This reaction chamber is already contain the catalyst. The catalyst is the mixture of cobalt, thorium, magnesium oxide and the calcium. In the presence of this catalyst and at the temperature range 200 to 300 and normal pressure, the carbon monoxide and hydrogen which are present in the water gas reacted in the different ratio in presence of catalyst and forms the various kind of hydrocarbons, saturated as well as the unsaturated hydrocarbons. Both are the formed in this reaction chamber. Since the temperature is high in this chamber, so at this high temperature all the hydrocarbons are in the vapor phase. So these hydrocarbon vapors are then passed through the cooler, and after passing the cooler, the hot vapors are condensed and the liquid is then now passed through the fractionating column. In fractionating column, the various fractions are collected as per their boiling ranges, and we collect the gasoline fraction for the further applications. That's all about the Fischer-Tropsch process. Remember, in Fischer-Tropsch process, the water gas is used as a raw material. The catalyst used is cobalt, thorium, magnesium oxide and calcium. Temperature 200 to 300 degrees centigrade. Okay, and pressure is the normal 1 atmospheric pressure. First two chambers are used for the purification. Iron oxide is used to remove the inorganic sulfur impurities. Iron oxide plus Na2CO3 is used to remove the organic sulfur. After purification of water gas, reaction chamber is there, in which in presence of catalyst at high temperature and pressure, normal pressure, various carbon monoxide and H2 hydrogen gas, that is the water gas, reacts in the various ratio and form the mixture of various kind of hydrocarbons, which are then separated in the fractionating column, and gasoline fraction is isolated or collected for the further applications. This is about the Fischer-Tropsch process. Now come to the second process of synthesis of the petrol. This is the Bergius process. In Bergius process, the raw material used to synthesize the petrol is the coal. Basically, the bituminous coal is used to synthesize the petrol. The catalyst used is the tin or nickel oleate in this process. Temperature range is 450 to 500 degrees centigrade near about. Pressure is 200 to 250 atmospheric pressure. First of all, the construction of the plant which is used to synthesize petrol in the Bergius process. In this process, first is the mixing chamber, second is the reaction chamber, third is the cooler, fourth is the fractionating column. So, first is the mixing chamber, in which the powdered coal is mixed with the catalyst and the heavy oil. So, due to presence of heavy oil, there is the formation of the slurry of the powdered coal with the catalyst. Now, this slurry is passed through to the reaction chamber. While passing, hydrogen gas is supplied to this slurry. So, carbon is received from the powdered coal and hydrogen is received by the passing of the hydrogen gas in this method. So, there is the carbon and hydrogen present for the reaction in the reaction chamber, and catalyst we already mixed in this. In the reaction chamber, the temperature range is 450 maintained and the pressure is maintained at 200 to 250 atmospheric pressure. At this high temperature and pressure, in presence of this catalyst, carbon and hydrogen reacts in the various ratio and forms the mixture of the hydrocarbons. Since due to the high temperature, the hydrocarbons formed in this chamber are in the vapor phase. So, all the hot vapors of hydrocarbons are then passed through the cooler, in which all the hydrocarbons are get condensed. Now, these condensed hydrocarbons are again passed to the fractionating column, in which different fractions are collected at different part due to the difference in their boiling ranges. So, first of all, at the topmost part, the hydrocarbon gases are collected, then gasoline is collected. After gasoline, middle oil is collected, and at the bottom part there is the heavy oil is present. Gasoline which is collected is further separated for the applications, while the middle oil is again cracked in presence of hydrogen to yield the gasoline, while the heavy oil which is collected at the bottom part of the plant is again reused to form the slurry of the next lot of the coal. So, the heavy oil is again and again reused to form the slurry and for the reaction. That's all about the Bergius process. So, just the recap that in Bergius process, coal is the raw material which is used in the form of the slurry, and to form the slurry, heavy oil is used. Catalyst used is the tin or nickel oleate. Temperature 450, pressure 200 to 250 atmospheric pressure. At this high temperature and pressure, in presence of catalyst, carbon present in the coal reacted with the hydrogen to form the different type of hydrocarbons. These hydrocarbons are then separated in the fractionating column, where we collect the gasoline fraction. That's all about the Bergius process. Now, next important topic is the knocking. Basically, knocking is related to the petrol engine or the internal combustion engines. In the internal combustion engine of a spark, If the quality of the fuel is low, then due to the immature ignition of air gasoline mixture, an explosive violence known as knocking is produced. Thus, knocking is the sharp metallic sound similar to rattling of hammer, which is produced in internal combustion engines due to the immature ignition. Remember, immature ignition of air gasoline mixture. Before complete understanding of the knocking process, we must understand the working of the gasoline engine. So in the next lecture, we start with the working of the gasoline engine. That's all for the today's lecture. Thank you.